The views and opinions expressed in this program are those of the speakers and do not necessarily reflect the views or positions of any entities they represent. This program is intended for educational purposes.
You're listening to
आप सुन रहे हैं
तुम सुनो था
നിങ്ങൾ കേൾക്കുന്നത്
ನೀವು ಕೇಳ್ತಾ ಇದ್ದೀರಾ
Radio Azim Premji University.
Hello and welcome back to our journey of math. I'm Shraddha, and with me on this podcast is everyone's favorite mathematics teacher at Azim Premji University, Mr. Divakaran. Welcome back. You'll have to say because people can't see you now.
Oh, that's true.
Just say hello.
Hello. Nice to be back.
It's a math world with Divakaran and Shraddha. Episode 2, The Zero Story.
What do you make of people believing that we learn a lot more math than we actually need?
I think it often stems from not recognizing what math truly is. And also because of the fact that the cost of failing in maths is perhaps a little too much in our society. So that all these add up to the fact that people don't have a good relationship with maths. But maybe outside the classroom, this relationship can be improved, is what I feel.
And this podcast is a small step in that direction. But what was probably different about the way you learned math and the way I learned math?
In fact, I will be very honest, I was not interested in studies till not just maths, any form of studies till my 8th standard or 9th standard, for instance.
Wow.
So I used to memorize everything and then go and write it in the exams and score decent marks. But I was not interested in studying at all. So then I chanced upon this book called Physics for Entertainment by Yakov Perelman. It's a Mir publisher book.
It's a very intriguing title, Physics for Entertainment.
Yes.
Why the title, Physics for Entertainment?
So the thing is, it's not asking you questions which are academic in nature, but it's more like curiosity questions. Like often they are framed in form of some puzzles or some kind of story, and you are supposed to answer those questions. So it's very, very entertainingly written. So that's something which first attracted to me to anything related to studies.
And at what age did you read this book?
This was in my 8th standard or so.
So I'm saying 13.
Yeah.
You must have been 13.
Exactly.
Yes.
So that's when I read this. My first love was not math, but physics.
Cue in romantic music.
And it's during the first 2 years of my undergrad program, I fell in love with maths, and that's when I really understood that even what I enjoyed in physics was the maths behind physics. So
Wow.
I realized that when I was doing my BSc.
All right. So are enough students reading this book today? Physics for
I
Entertainment?
doubt that.
The biggest takeaway from today's episode is buy that book, Physics for Entertainment. It changed the course of someone's life, and that someone is sitting right in front of me right now. So in the last episode, we saw how at least 4 civilizations had place value system for numbers. They had cracked a way to represent quantities, but they did not have zero. So representing large numbers without zero was so confusing until India said, zero, just put a zero there. So there is a difference between 404 and 44 and 440, and the world had a eureka moment.
The concept of zero as a number was discovered only once in the history of humanity.
Yes.
And that was in India.
Right.
When I say that, however, a symbol for zero was discovered 3 times in the history of humanity. Once by Babylonians, once by Mayans, and once by Indians.
So, but then the Babylonians and the Mayans, when they made that symbol for zero, was it a symbol for zero or was it a symbol for not any of the other shapes?
It was a symbol to denote the absence of any number in that particular place.
Right.
So the absence was denoted by that symbol, but the symbol itself did not represent any number.
Much like a space bar.
Much like a space bar. Just that a space bar, we cannot distinguish between 2 space bars and 1 space bar.
Right.
Or even if you can distinguish between 2 space bars
You don't
and
know
1
if it's 2 or 3 or,
or 10 or 11.
Yeah.
Right? That's really
Right.
difficult to distinguish.
Right.
So to ensure that you can distinguish between n space bars and m space bars,
Right.
people started using these symbols. And it only meant that.
It might have as well been like a dash.
It might as well
A
have been a
series
dash.
of dashes means not the symbols that you know
Exactly.
of. Yeah.
They could not have added 2 of these symbols or something like that.
Right.
Or multiplied. So they were not numbers in the strict sense of what in the strict sense of the word.
Right.
So that's what was different in the Indian conception.
Right.
We could add 0. We could add 0 with any number. We could
Correct.
add 0 and 0. We could multiply 0 and 0. We couldn't divide though.
Yeah, because I think why would you need to divide by 0 was a question I had. Like, why do you even think about this? Like, why will you ever need to divide by 0 and hence come up with infinity?
One of the situations where you need division is when you are cancelling out terms on both sides of an equation.
Right.
Right? This is something which we all do, right? 2a is equal to 2b means that a is equal to b.
Right.
How do we do that? We are dividing by 2 on both sides.
Right.
But 0a is equal to 0b does not mean a is equal to b. And that
Right.
we all know that.
The
right?
whole LHS equal to RHS thing that we need to do.
Exactly.
But again, there, it would mean infinity plus 2 is equal to infinity. Then removing infinity from both sides would give you 2 is equal to 0.
So now you are bringing a different concept altogether. So far we were talking about numbers, and in these numbers we were not including infinity as a number, right? So this is a new monster that has come into our garden.
Yeah.
0 itself was a monster to the garden of nicely behaved numbers, which we can add, multiply, subtract, and divide. We suddenly introduce 0 and we no longer can divide. We can do all the other operations, but not division.
Right.
So it's, in some sense, it's already a monster in this garden of numbers.
Yes.
Infinity is an even bigger monster in some sense.
So
right?
in that sense, the two of them are mutants. So to
The
speak.
two of them are mutants, and in some sense they are related to each other. Like
Right.
they are related to each other, and the relationship between 0 and infinity is something that has fascinated humanity for a very long
Right.
time. So, in fact, I think you have struck the important point there, because in some sense people think of 0 and infinity as reciprocals of each other. 1 by 0 is often thought of as infinity, and 1 by infinity is often thought of 0. So in some sense they are reciprocals of each other is an intuitive understanding that people have, right? But at the same time, we don't typically use these when we deal with numbers. We don't deal with infinity, like division by 0 or the number infinity at all. Infinity is not usually thought of as a number. Unless once we start working with complex numbers, then there is a better way of making sense of infinity. The place value system, the neat place value system that we have today is impossible without a 0. However, somehow the other civilizations like Babylonians, Chinese, Mayans and all could do without it. And they could do most of the computations. So it's not like the discovery of 0 helped us tremendously in computations. In fact, the Chinese could do like the algorithms for computations that the Chinese came up with were very similar to the algorithms that the Indians discovered. So there's not a big difference between 0 did not really help in computations that much. The only thing it helped was that for the Chinese to do these computations, they needed some devices. More mental arithmetic was kind of possible because of 0. But apart from that, it really did not help in computation so much. However, it helped us understand the similarity between these various systems. Without the 0, the Babylonian system, the Mayan system, and the Chinese system and all looked somewhat different from each other. The similarity between these various systems became more evident when we started thinking of these as a proper place value system and things like that.
Oh.
So
So it was more like, wearing a pair of 3D glasses to actually see, make sense of.
So yeah, it's in some sense like a 3D glass or something, which gave us insights that was not yet available to us.
Right.
So for example, there is this brilliant work by Pingala on actually language. So he was interested in this idea called prosody, which is about the sound pattern in poetry. You might be familiar with the fact that there are these meters and things like that, which
the rhyme scheme,
meter, like which is about how many syllables can be there in a line, how many of them are long, how many of them are short. There are these lots of rules in earlier poetry. He made different molds for poetry that would sound good to people. So, and he was studying these different patterns that would sound good and things like that.
Okay.
But his work in prosody can now be interpreted as a study of binary number system, because these long vowels or long sounds can be thought of as 1, and the short sounds can be thought of as 0 and things like that.
And what could be the possible application of this inference? Has this inference been used?
The language of binary numbers makes some of this analysis a lot easier, because now it's just a computation. Doing something there is equivalent to doing a computation here. So that actually simplifies things. So there are two things. First of all, it simplifies things. Secondly, something that always fascinates mathematicians is when there are two seemingly different things which are connected, it's a sign that there is something deep going on behind it. And this is something that really fascinates people.
Yes, so coming back to, now that we have all the numbers, we have all the shapes that we need, and then how soon before we said, let's have fun adding and removing and multiplying, and how soon did we get to that?
So, actually, as I mentioned earlier, like this addition, multiplication and all were very much there before we had zero.
Right.
People, Chinese and Babylonians could do computations very well. In fact, we did not even need a place value system to do addition and multiplication. There were systems of numerals which are different from place value system, but were well equipped to do addition and multiplication.
Right, because we had the symbols. We might not have had zero, and that would have caused some confusion, but because we had the symbols, we were adding, subtracting, possibly multiplying. Now with the arrival of zero into that garden, how did that change everything? Or what was the new way in which we said, now we can finally add, subtract, multiply properly. Finally.
Place value system facilitated addition and multiplication.
Right.
Zero did not facilitate addition and multiplication in any significant way. What zero has done are three things. First of all, it has helped us understand the underlying unity between seemingly different concepts. Secondly, now we are thinking of absence as a number itself, not just other numbers. Like we have started counting in a different way. When there is base 10, I am thinking of ones place, tens place, hundreds place, thousands place, and so on. In all of these, there is ones place. Why is ones place making sense? To make sense, why can ones place exist in all of these different place value systems?
You need to know that it's 10 raised to 0. But there is no 0. You don't know of 0 yet.
Without 0, you could not have seen that. You would have thought of 1 as an anomaly, for instance.
Oh, all right.
But now 1 is no longer an anomaly.
And it's an anomaly only when you're looking at 2-digit and 3-digit numbers. On its own, it still makes sense to you. Yeah, 1 makes sense, 5 makes sense.
So one's place was an anomaly, is what I'm trying to say. But one's place is no longer an anomaly if you have 0 in your concept.
My goodness, things that we cannot even imagine can confuse us today were actually huge points of debate or huge puzzles back then.
Yes.
So the ones place could not make sense to the Mayans, to the Babylonians.
No, individually it makes sense to them. So the ones place made sense to them, but the ones place for Mayans and the ones place for the Babylonians seem very different from each other, right? But
Right.
they are not, is what we are trying to say.
Oh,
So how
right.
are the two different systems related to each other
Right.
is the point that we are trying to make here.
All right. Makes me think that we need a zero to do the same thing to religions as well. Isn't it? Can somebody invent that zero that says all religions are saying the same thing? It's the same thing. Wow. So zero did that to numbers.
Yes.
What nobody has been able to do for religions
Zero
today.
showed
Wow.
us that these seemingly different systems are all actually using the same principle. Concept is same between all these different systems.
Right. Oh.
It
right.
really helped us understand that.
Right.
So that is
And that's why there is peace in the world of mathematics and science. There's still peace.
and
but
this,
no.
this also makes me curious about one thin. So nowadays this is gaining popularity. It's gaining popularity that like some aspects of calculus in the modern language were discovered by mathematicians from India, more specifically coast of a particular river in Kerala.
What's the river?
It's called Nila or Bharatapura.
Huh.
It's coast of this river.
So a lot of mathematicians arose or came from this place?
Yes, in a very small, tiny locality.
Wow.
I come from that locality.
Wow.
So I'm very proud personally.
Nila.
Nila.
Huh.
Mathematicians from this small locality actually came up with certain aspects of calculus, not the entirety of calculus, more specifically representing functions as what is known as series. So this concept, mathematicians in Kerala came up long ago, like roughly 200 years before Newton.
The binomial theorem and...
All these ideas were there in Kerala.
Wow.
So, and one thing that I feel is, that I think about, this is complete speculation, we don't know anything, I'm not sure about this at all, but I was thinking that, see, the concept of zero or the concept of the modern numeral system became popular in Europe only in 12th century. Commonplace only in 15th century or something. So does this have any relation with each other? The fact that did Europe discover these ideas later because the number system reached there later.
Oh.
So we had the advantage that we had this number system earlier. Therefore, we could do this more complicated stuff. But the Europeans did not have the luxury of these nice number systems.
We were trying to solve problems the Europe did not know exist.
Exactly.
Right? But then, do we have documents to prove this?
Not really.
Don't,
not
because
really.
we got invaded by all powers who are not busy doing math. If everyone was busy doing math, we would still have all the records to show. You're thinking that might have been the case.
Yeah.
You think that might have been the case.
There is this brilliant book by Charles Seife called Zero, the biography of a dangerous idea. In that book, actually, he talks about various ideas that probably came up only because the concept of zero was invented.
Wow.
And actually, this earlier idea of thinking of taking tangents as making sense of 0 by 0 was also taken from that book.
Along with negative numbers, the ancient Indians were happy to include 0 in their number system. It fit neatly between the positives and the negatives. But they still thought it was sort of strange. Multiply anything by 0 and you get 0 again. As for division, well, that's chaos. How many zeros are there in 1? The 12th century Indian mathematician Bhaskara realized the answer was infinity. Incidentally, infinity had strange properties too. You could add or subtract any number and it stayed exactly the same.
And he talks about multiple ideas within mathematics, physics, everything which kind of has the same flavor to it.
Right.
And I highly recommend you to have a look into that book to get more examples of such things. I feel what this means is that this has really become so much part of our culture. Like without 0, we cannot even think of anything. So
Right. So we cannot imagine a time when people couldn't get their head around 0. And once 0 came in, we were saying, okay, let's figure out what our place in the sun is and let's measure what is that angle and, how far this is and how close this is and how fast we are going about in the universe.
Some of these questions might have existed before, but at least it allowed us to answer these questions way better.
Maybe those questions existed, but were answered very philosophically.
Exactly.
And not mathematically.
Exactly. Now we have very good answers to these questions.
Right.
Hi, I'm Giri.
And I'm Raghu.
So Raghu is 77 and I'm 67. And we've been following cricket like mad for the past 60 years.
I learned the English alphabet spelling Umrigar and Hazare and Mankad.
Raghu saw his first cricket match in 1955. I saw my first cricket match in 1963.
So the first test as an Indian team which we played was well before we got our independence in 1932.
Governor Raja Maharaj Singh joins thousands of eager spectators.
The whole story changed in 1961-62 tour because Nari Contractor was felled by a bumper from that dubious bowler called
Charlie Griffith.
Charlie Griffith, known as Charlie Chaka.
So Charlie Griffith has struck again.
By the time the 1980s began, the spin quartet had gone. Kapil had arrived and India had a pace attack for the first time in its cricket history.
पाकिस्तान के मुकाबले में ये पहली विजय प्राप्त हुई है. कपिल देव को मैन ऑफ द मैच चुना गया.
The inflection point is the 90s. Doordarshan would go say, can you please show this match? You now had people saying, can we host your match? The money started coming from there.
Some of the most amazing things that have happened in the last decade, which includes women's cricket, media, analytics, and the way the game has changed in this last decade.
In Well Caught by Raghu and Giri, hopefully you'll get a sense of how we must have fought and discussed and come together to write our books.
Brilliantly caught. Absolutely magnificently caught.
Well Caught by Raghu and Giri. Enjoy the show.
Coming soon, only on Radio Azim Premji University.
Meanwhile, in Egypt, people were adding, multiplying without a place value system.
I said earlier that zero was not essential to do computations, but place value systems really played a big role. But the people could do computations even without a place value system.
Right,
so we should not think that the Romans did not know how to compute or the Egyptians did not know how to compute and so on.
Right. What we are getting at is that our ability to add, multiply and subtract precedes our understanding or invention of the place value system.
Yes. Okay. Precedes is now difficult. Precedes not chronologically, but precedes within a culture. There were cultures that did not have place value system, but they could add and multiply. But the Babylonian place value system is so old that it predates the Egyptian system.
Oh, right.
But the Egyptians did not have a place value system.
Correct. But they were still adding.
But they were still adding, they were still multiplying and so on.
Got it. Now
Right?
I understand.
That's the scenario here. So it's natural to ask, how did they add? How did they multiply and so on? Addition is generally not so difficult. I think if you spend some time, you can come up with how they could have done that. Multiplication is the more tricky aspect, right? And what they did was they made a simple observation. Suppose I wanted to multiply two numbers. Multiplying these two numbers is the same as multiplying the half of one number and the double of the other number.
Yes.
Right?
Yes.
Multiplying A and B is same as multiplying A by 2 and 2B. Suppose we wanted to multiply 1000 and say 27 or something like that. Of course, in the place value system, especially with the 10, 1027 is very easy. You just put 3 zeros after 27, you get 27,000. But of course, they did not use the place value system with base 10. They did not use that. So 1000 is something complicated for them. 27
it's a complicated symbol. It's not the way we are imagining right now. 1 followed by 3 zeros. So our viewers need to imagine some sort of symbols they don't recognize as a number called 1000.
Exactly. But if you notice, 1000 is very close to 1024. Very close to that.
Right.
Right? So 1024 multiplied by 27 is same as 512 multiplied by 27 into 2, which is same as 256 into 27 into 4, and so on. So this I make this observation. So
and were they doing it with both hands, ambidextrous? Half with this hand and double with this hand. Oh my God. It sounds very complicated.
So they have these tables to use. That is exactly what they were doing.
Okay.
So you only need to know how to multiply by 2.
Right.
Right? If you know how to multiply by 2, then you are done. Right? So if you somehow know how to multiply 27 by 2, then you are done.
Then you can multiply 27 by 1000.
Yes.
Add 27 by any number.
Any number.
Oh.
But there will be a small error. Right?
Correct.
Because I am not multiplying by 1000, I am multiplying by 1024.
Correct.
How do I
account for that error?
How do I account for this small error? One way is to do is, okay, 1024 is a little too big. If I want to make this precise, I should have started with something smaller. So what I would do is, I will represent 1000 as powers of 2. 512 plus 256 plus 128 plus something. Right?
As a sum of powers of 2.
Yes. I can express 1000 as a sum of powers of 2. And the moment I have expressed 1000 as a sum of powers of 2, I know how to multiply 27 with each of those.
Ah, okay.
Now all I have to do is add those numbers. And addition I am comfortable with. So I have reduced the problem of multiplying with any number to the problem of multiplying with powers of 2.
And adding them.
And adding them. And I have reduced the problem of multiplying by powers of 2 to the problem of multiplying by 2.
So you are adding 27 into 2, 27 into 4, 27 into 16, 27. That's what you're doing.
Exactly. So if I had tables of so what they did, they actually in practice what they had were enormous tables of multiplication by 2 and division by 2.
And these are not printed on paper.
These were not printed on papers. They were on like some clay tables or stone tables or something like that.
Okay.
They had these enormous tables, and these tables were, so it's like how we use logarithm, right?
Or abacus.
We have this we have a log book which we look and say, oh, this is a logarithm. And logarithm was also used in school as a tool to multiply.
Correct.
If you
yes.
So the same kind of technique they were using. They had an enormous catalog of these doubles and halves, and this catalog was used to do their computations.
My God, you reminded me of logarithmic tables. We had those little booklets printed on very poor quality paper.
Correct.
And were using ink pens. After the first 3 classes, you could not read any numbers because they would have blots of ink on all of them.
Correct,
and then you'd be like, buy a new one now. Goodness.
Clark's tables, they were called at least.
Yes. Okay, all right.
So
really, logistically speaking, also difficult with the tablets of tables to be carried around or installed.
So again, maybe what helped is, again, the fact that not everybody did these computations, only specialized people did these computations. So that probably helped them, right? So they had their offices which had these large tables and something like that.
Right.
So probably that's the way things work. It's not like everybody in Egypt did these computations. There were clear division of labor and only some people did these. So that now in our world, that's not the case.
No.
Everybody.
So when you say there were clear divisions, there were other people in Egypt who were using other forms.
No, they did not do any computations.
Oh.
Only these people did computations.
Oh, is this a level thing?
Yeah, it's a level thing in some sense.
Oh my goodness! In every society, you cannot add or subtract or multiply. You can only identify numbers.
It's not like you are not allowed to do. I don't think that was the case. It's like how in modern world, writing software is done by a few people.
Right.
Everybody used software, but writing software is done by a few people.
Oh, okay.
In that era, multiplication was as difficult as what writing software is right now.
Okay.
Right?
So it was a specialized skill.
Exactly.
All right.
It's a very skilled labor. Right?
So you guys can just carry those tablets and bring it to my room. I know how to read and do the rest. So yeah. Oh my. Imagine just multiplying 1000 with 27 was half a day's job for someone. Like, oh, I forgot my tablets. Could you go to the other guy and just carry his? Just a 10 minutes. No, half a day actually. Cannot imagine.
This and again, see, in the interpretation that I told, I've already introduced binary numbers into it. The representation with base 2.
Yes, base 2.
But that is a modern perspective. So the modern perspective is allowing me to visualize or understand the Egyptian system, which actually was a very complicated looking at tables kind of algorithm.
Yeah.
But I am understanding it as a binary arithmetic or something like that.
So there was the base 2 system before the base 10 system. The base 10 system happened and we thought we have simplified things. Then there was, no, things could get much simpler with computers, but we'll have to go to the base 2 system.
Correct.
Whoa, that is so amazing. Wow, the back and forth.
Yeah. So Egyptians used the binary system without realizing they are using binary system.
Right.
And then came many other systems, including the base 10 system that we used and became popular throughout the world.
Right.
But then with the advent of computers, we went back to the binary system.
Correct.
And now we all realize how important binary system is.
That is. Wow. And in the middle of all that, there is also the base 60 if you look at your watch.
Correct.
So they're all coexisting so beautifully. This is amazing.
Make sure you check out the show notes where we share the show resources and acknowledgements. And don't forget to subscribe, like our channel for future episodes. On the next episode.
Yeah, but Indians also got invaded and all our records were like set fire to. And I feel Pythagoras had that advantage of being in Greece and not being invaded enough for his records to be burnt. Pythagoras!
You're listening to
आप सुन रहे हैं तो इन सुनो था
നിങ്ങൾ കേൾക്കുന്നത്
क्यों കേൾता इधर
Radio Azim Premji University.